those handy to use, please, please, please. All right, so today we are solving equations using Nth Roots. We have a worksheet today. Second period did pretty good and got almost all the way done. So you do need to finish it though. And there are some tricky questions. I'm going to say check your answers. So solving for x, we're going to go back to what we did first semester. We have some examples of some problems we solved first semester. X, some number squared equals 16. I want to isolate the x. What can I do? Square root. You can take a square root of both sides. When you take a square root, what did we need to remember? There's two answers, always plus or minus. That was the big thing. Don't forget the plus or minus. Don't forget the plus or minus. The square root and the square undo one another. They cancel each other out, leaving x all by itself. And we get plus or minus. What is the square root of 16? 4. Yeah. So we get two answers. And so this was a big thing. If we were taking a square root, we wanted to remember, don't forget the plus or minus. Well, we just learned about rational exponents. And if I have the square root of x, then I can also write that with a rational exponent. X to the 1/2 means the same thing. Remember, that's power over index. Index, the number in the elbow there, okay? And so today, we want to show how using those rational exponents is actually quite nice, all right? So here, well, I'm not going to do it for that one. I'll do it for this one, though. Again, we're trying to solve for x, but right now it's trapped inside parentheses, so I need to do something to get rid of the power. How do I get rid of the power? Square root. So we're going to take a square root of both sides. Don't forget the plus or minus. The square root and the square cancel out, leaving x minus 3 equals, what happens here? Let's see, the square root of negative 25. What's going to happen? Imaginary, non-real answer. We cannot take the square root of a negative number. It's a non-real answer. So we're going to say imaginary. This one has no real solution, no solution. All right, so we're going to pay attention for no solution answers today. All right, so last one here. We want to solve for x. What do you think we need to do first? Eventually, if we want to get rid of the 3, yeah, if we didn't do any adding or subtracting, we need to isolate whatever's being squared first. So we want to actually add the 3 first. So we have x plus 4 quantity squared equals 13 plus 3 is 16. All right, now we can do what? Square root. Here's another thing we can do. A square root is the same as a 1/2 power, which is kind of interesting. The reason we like rational exponents is because in this situation, we end up multiplying our powers together. 2 times 1/2 equals what? Becomes 2 over 2, which reduces to 1. These powers end up canceling one another out. And we're left with x plus 4 to the first power, which is just x plus 4. All right? So those rational exponents are kind of cool. The other thing is that 16 to the 1/2 is something I can put into my calculator. The only problem is it's the square root of 16. We need to remember the plus or minus. What is the square root of 16? 4. Yeah. Your calculator won't tell you the plus or minus. But anytime we're taking an even root, when that index is even, we want to remember that plus or minus today. Is x by itself? Not quite yet. So I'm going to subtract the 4 and move it over. So I get x equals -4 plus or minus 4, which we're not done yet. What is -4 plus 4? 0. And then -4 minus 4. -8. So we get 2 answers, which is kind of nice. So we're sort of combining solving today with our rational exponents. And what we want to do is remember anytime that index is an even number. So if it was something to the 1/4 power, we'd have that index as an even number, or 1/6 power. We want to remember that you need to put a plus or minus on there, okay? Just like square roots had a plus or minus, any even root, any even index needs a plus or minus as well, okay? Other than that, it's pretty good. So let's see how that applies. You're going to want your calculator out. Example 1, solve for x. Check your solution. Check, 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 check. I don't know how many times I can say check. It's really important that you check your answer. Solve for x. Make sure you're writing the directions down. Example 1 and the directions, please, please, please. All right. So I want x by itself. What do I need to get rid of? The power. That's right. Okay, so if I want to get rid of a power of 5, I can raise it to the 1/5 power on both sides, which is very cool. Remember, this is power over index. And that index, is it an even or an odd number? Odd. If it's odd, I don't care about it. Odds always work. What happens when I multiply 5 times 1/5? Yeah, if it cancels out. 5 times 1/5. Multiply those powers together, you get 1. Cancels out. Nice. That's called the reciprocal. So you get x to the first, or just x. This whole left side is something you can do in your calculator. Notice the parentheses. You must put it in properly. So here we go. Parentheses, -243, caret, that little crazy looking arrow. -243 with that little funky caret thing to the 1 divided by 5 power, please. Just like that in your calculators, 1/5. And it gives us our answer, which is -3. -3. And that's our solution for x. Kind of nice. The 5th root of -243 is -3. Okay? You can check your answer by taking -3 and plugging it in for x. So -3 to the 5th. -3, and you got to make sure that you do the parentheses on that. -3 to the 5th equals -243, like it should, right? So always check. It's a good idea. You have calculators, just no excuses. All right. Our x is trapped right now. What do we need to do to get rid of this power? The reciprocal. What is the reciprocal of 4/3? 3/4. So we're going to take a 3/4 power of both sides. And when we multiply these together, we would get 12 over 12, and 12 over 12 is 1. And that is why reciprocal powers are so cool. So the first power just means x minus 2. So now, this really means the 4th root of 16 to the 3rd power, power over index. We're taking a 4th root. What do we need to remember? We're taking an even root. What do we need to remember? Plus or minus. Always, always. So anytime that index is an even number, you need to remember the plus or minus. The nice thing is we can just plug it into our calculator. 16 to the 3/4. 16 to the 3 divided by 4. Whoops, I wrote 4/3. That's funny. 3 divided by 4. How about? And we get 8. We just need to make sure that we put on the plus or minus. Plus or minus 8. The 4th root of 16 is 2, and 2 cubed is 8. So we get plus or minus 8. Okay. All right, I need to get x by itself. What do we need to do? Add the 2 over. So that's going to give me 2 plus or minus 8, which then I need to figure out. What is 2 plus 8? 10, and 2 minus 8. -6. So there's 2 possible answers here. I want to check them real fast. I'm just going to use my calculator to check. I'm going to plug in place of the x. I'm going to plug in the 10 first. Make sure you use the parentheses. So we have 10 minus 2 to the 4/3. Oops. And that should equal 16. Yes, it does. 10 worked. So now I'm going to plug in -6. -6 minus 2 to the 4/3. And again, it also equals 16. So that one worked as well. Okay? Plug those back in. Questions on these two? Hang on there. Two times the quantity, x plus 4 to the 2/3 equals 18. What do we need to do first? Get rid of the 2. Very good. Can I distribute the 2? No. We cannot distribute the 2 because the exponent has to happen first. So we can't multiply by 2 in there. The easy thing to do is actually divide it away. This is 2 times the group. We can just get rid of it by dividing. So then we have x plus 4 to the 2/3 power equals what? 9. Good. Now how do we get rid of our power? Reciprocal. Yes, a reciprocal power. 3/2. We're going to do a power of 3/2 on both sides. On the left, we get 6/6, which is 1, so that goes away. We get x plus 4. Now, what do I need to remember on the right side here? So it's power over index. This index is even, which means what? Plus or minus. So I'm going to put on the plus or minus, but then I can just use my calculator. 9 to the 3/2 power is 27. So plus or minus 27. In case you're curious, it is the square root of 9 cubed. The square root of 9 is 3. 3 cubed is 27. So you can do it by hand as well, but you can use your calculator. It's totally fine. How do we get x by itself? Subtract the 4. So I'm going to move the 4 over by subtracting. So -4 plus or minus 27. -4 plus 27 is 23. -4 minus 27 is -31. 2 possible answers. And again, I'm going to check those answers by dropping it in right here, dropping in 23. And just make sure that it works. So I have a 2, parentheses, 23 plus 4 to the 2/3 power. And it equaled 18, so we did that one right. And now I'm going to drop in the negative 31. So 2 parentheses, negative 31 plus 4 to the 2/3. And again, it should equal 18, which it does. So both of those work. Please check your answers. Last one. What do we need to do for letter D first? Get rid of the 3. Absolutely. Subtract the 3. We have x minus 2 to the 3/4 power equals 8. Now, how do we get rid of the exponent? Reciprocal, the 4/3. 4/3 power. What happens to the left side? You get 12 over 12, which reduces to 1, so that goes away, just leaving us with x minus 2. What about on the right? Do I need to remember anything here? No, this is an odd index. We do not need the plus or minus there. So that's just something I get to put in my calculator. So we can do 8 to the 4/3. What do you get? 16. 8 to the 4/3. Again, if you wanted to do it in your head, it'd be the cubed root of 8 to the 4th power. So the cubed root of 8 is 2, and 2 to the 4th is 16. We don't need the plus or minus there. We're going to go ahead and just add 2, which gives me 18. And again, I'm going to check my answer. I'm going to just go right up here and drop in that 18. So 18 minus the 2 to the 3/4 power. So I'm up here in the exponent position. To get out of that, you just use the arrow and arrow down, arrow over, and then plus 3. So the whole left-hand side goes in the calculator, and it gives me 11, which is what we want for the output. Okay? Do you have questions for me? How do you know if you need a plus or minus? The power over index, if that's an even index, you need the plus or minus, okay? Please check your answers.